Hi.
Hello everyone and welcome to this series where we'll be covering WebGPU and we're going to try to go a bit into 3D and try to create a simple PONG game. It will include some environment maps, so that's going to be exciting, and then I'm also going to do it split screen later on in this series, so that's also exciting. So first of all, this is not introductory course into WebGPU. There is my other series for that, and I'm going to link in the description of the video below. Although I'm going to explain quickly WebGPU if someone wants to get on the speed. So what it is? Well, it's a rasterizing API, right? Rasterization means it just draws triangles to the screen, and it's similar to APIs like DirectX, OpenGL, Vulkan, Metal. And WebGPU specifically is more modern one, so it's less similar to the DirectX 11 and OpenGL, and it's kind of similar to in philosophy to DirectX 12, Metal, and Vulkan. And it's also a wrapper around those. So whenever you use WebGPU, indirectly using either Vulkan, Metal, or DirectX, there might be cases where it might use OpenGL, depends on the implementation, but generally it's a layer around modern APIs. Uh, so that's that for WebGPU. So we're going to use it on a web. You either have WebGL or now WebGPU, and for that you're going to need Chrome. And I would recommend downloading the latest Chrome because it's still not available in all the browsers. So Edge or Chrome, preferably Chrome. I think it might be a better option. And then just for the environment, we're going to be using TypeScript, not JavaScript, mainly because safety of the types, and it's just way easier API to work with. And for that, you're going to need to have Node. You can probably go with lifetime support or the kernel, whatever you prefer. And then you're going to need to install Vite. I'm going to show how to install it on Node. So once you install Node, you can just go basically to your command line, git bash command line, whatever you have, and then you can just install with Node. You can say npm install and then say with and globally, and that's going to install it. And for Mac and Linux users, you probably need to add sudo for you to be an admin, and then you just install it. uh, and so I'm already in folder where I want to create my project, and here since now I have Vite, right, I can check something like that. Okay, it's here. I'm just going to clear it because it's confusing. And then we're going to create a Vite project. So we can just say npm create Vite latest. And here it's going to ask about the name. I'm going to name my project PONG. It's not that important. For framework, we're going to use vanilla. So vanilla means no framework. And then I'm going to select here TypeScript. And that's it. So we just navigate folder, like it says, cd pong, we install dependencies, npm install or I, and then we can run our Vite project in a second. So let's try to do that. Npm run dev. We're running on local server, right? HTTP 5173. If I copy paste it here. All right, that's the project. So from now on, I'm going to be working split screen with this, and then I'm going to be using on the second screen. It was supposed to be Visual Studio, but I'm just going to create a new instance, and then probably open that project, right? So it's somewhere. I keep it on desktop, so just it's easily available. WebGPU, PONG, and we're good to go. So I'm going to move this here. Okay, it's full screen. Resizing on Mac is kinda a bit weird, inconvenient, and we're here. All right, that was quick introduction to Vite and npm. And like I mentioned, I'm not going to waste too much time with that. I have other series for it, but here we're just going to clear stuff up. So we don't need this counter, we don't need this main, we don't need styles, this SVG. I'm going to leave with environment, and then in index file we probably don't need this app. If I save everything, and I did not save everything, so it will automatically refresh everything. A second, let's save all, and it's empty, and that's quite all right. So we can start with WebGPU now. So first things first, we need to discuss how do we access WebGPU, and we access it through the canvas element. So in our index, somewhere in our body, we can add canvas here, and I'm just going to set width to something like 2000. Like, yeah, this is fine probably. You can use some other width and height. I'm going to go with this one, and then I'm just going to give it an ID so that it's easy to reference from our TypeScript code. And that should be it. It should create a canvas, and I'm just going to edit site style, background color, maybe red. Okay, it's there. So I'm just going to use cyan. Alright, we have our canvas created. That's perfect. And now we can start with actually WebGPU. So I'm just going to create a small function where I'm going to load stuff. So it's going to be async function init. And then we're going to call it. Alright, perfect. So how do we get the WebGPU? Well, first of all, I'm not going to say this. I'm going to say fetch canvas. So we need to fetch canvas, and how do we fetch it? Well, we just get it like this. So if you remember, ID was canvas, and then we need to fetch GPU context. So when you're working with canvas, it has this idea of a context. So context can be either 2D for 2D drawing. I never used bitmap render. It can be WebGL, WebGL2, but it can also be WebGPU. And then here, all right. So another problem, and I forgot about this. We don't have WebGPU types, so let's just install that quickly. And I think I know what it is. So basically, these types, since WebGPU is kind of experimental for now, not part of the standard. I'm not sure where it is exactly the state now, but it simply doesn't have these namespaces. If you have this problem, we can bring up here the terminal. So, or you can do terminal from folder, it doesn't matter. And we can say npm install. This is dev dependency, so //save/dev. And then we can just say here at WebGPU types, I think. I have it in other project. Yeah, I think that's it. And then we're just going to go include them in our config file. So TypeScript needs to know about this. And then here, somewhere below, we can just say types. And what was it called? It was called add WebGPU types. So we're just going to add those type definitions. If I save all, I think it might be even working. So let's try. Ah, here it is. So now we have WebGPU definitions. And from that, we can actually start creating it. So first of all, you fetch the context. So that's just the context. We're still not working with the device. So we need to fetch this device. And device, how do we fetch it? Well, we fetch it from the navigator, then we have GPU request adapter. You're going to see it. So you fetch the adapter, and the idea behind the adapter is it kind of represents your possible adapters, your accelerators. In your case, it's probably going to be graphics processing unit, but it's kind of written in a way that accelerator can be something else, but you can also have multiple graphic units. So we're just going to use the default one. So if you have multiple GPUs here, it might request like, for example, integrated one or dedicated one. And you can probably set preference here if you wanna. So you can say power preference, high performance. So it's probably going to be dedicated in this case. I'm just going to leave it because I'm on Mac, and for me it's always going to probably select the integrated one. I don't have the dedicated one. Anyway, I'm rambling here. So next, what we need to fetch is actually the device. And here you can also check if not GPU context. You can probably throw an error here or alert. so WebGPU not support, then return, because this will be the case if your browser doesn't support the WebGPU for sure. And now we have a device. So device is actually an interface that kind of represents your GPU processing unit. So you can also say, if you don't have a GPU, you can do these error checks. I'm not going to do that. One thing that we need to configure with context, we need to configure context for rendering. So you do that via GPU context, and then say configure. You paste in the device, and then just the format. So this is the format that we're going to be using. So it says color 1 is blue, green, red, alpha. But you can also say something like GPU context and then canvas. I don't remember. It has some command like get preferred format. It's not that important. We're just going to use this. It's fine. And then what we now have the GPU context and everything, and further we're probably going to need to draw to our canvas something, and let's do just that. So here, how do we draw? Well, first of all, we're going to do our frame. So here we can say our const render or draw, even better, draw is a function, right? So we're just going to create a function. Okay, sorry about this. It needs to be a function which is going to be requested for next animation frame. So and then you just need to call it here. So what's this going to do is it's going to call draw. We just need to call it once, and then request animation frame is updated every 60 seconds. So it will call the draw every 60 seconds or so if it can make it. So this is just like writing a while and then calling draw all the time. It's just the better way to do it in JavaScript. So you could write a while through and then request draw, or you do this, which is better way of doing it. And then we need to discuss a bit how do we call commands of WebGPU, how do we pass data to the GPU. So let's do that. So about sending data to the GPU, right? We're going to do it via command encoders. So we can just here create a command encoder, and then we submit those command encoders. Idea is to submit them to queue, and here be careful, this is an array. So you just I don't know why it's this, but we're just going to use device, right? We're going to fetch the queue and then submit the commands. So it kind of works like this. You basically have this idea of a queue. All right, this is, so you have this idea of the queue and everything that you want to do on the GPU, right? Our graphics card. You kind of do it in a queue, right? You could do render passes or compute passes. So you can do rendering. Compute pass is when you use compute shaders, which is for general programming, or you can do, there's this idea of split commands, which is just used for copying data really fast. And then you push all of those into commands so that there can be multiple render passes and stuff like that. You push them to queue, and then the queue is executed on the GPU. And the first thing that's in the queue will be the first one that gets executed. So let's say that this is the first one, it's going to get executed. For you, it really means just you need to do this, you need to push to queue, and then that's it, right? You don't have to worry about it. Your commands are pushed to the GPU and it will execute them. So how do we do rendering? So for rendering, we're going to need render pass encoder. So you kinda do this begin render pass. So this will be our rendering pass, and rendering pass. It's pretty clear what it does, right? It's supposed to render stuff to screen or to off-screen texture. So we're going to cover that, and then so where first property here is kind of important. and this is wrong, so I'm just going to finish it here. Color attachments is wrong, but I'm going to fix that. So first property is view, and that's important. So where do we want to render to? So you can either render to off-screen texture, or you can render to canvas texture, right? And this is GPU canvas context. You ask for a texture, and then the WebGPU has this idea of views into texture, so you just say create view. It will create a view into your texture and then render to it. So now we're rendering to canvas. Then we have this store op, which is store. Yeah, it will just store information to the text, to the Jezik canvas texture. So we have this idea of clear value. So how do we clear our canvas? So I can either clear it to black or to red color. So it's still not working. You're going to see it in a second. And load up. So what do we want to do with the texture? Well, we just want to clear it, right, at the beginning of the frame, and then we just in order to finish with it, we just say end here, render pass end, and then it's kind of submitted to do our command encoder, right? Created command encoder, command used begin and the pass. Now it's done. It's on our command encoder, and then we submit all of those commands. So you can play with here with this, and then you can clear the color. So this clear color thing, it's just so that you basically clear the canvas element texture to some color. All right, that's it for that part. The next part is actually, well, this is boring, right? We're just now clearing the canvas. Next part is we're going to try to create shader and then to render some kind of triangle on the screen. So we can say here shaders, and the first shader, and we're going to play with it a bit more in the future, but for now I'm just going to do this. I'm going to call it unlit material shader, and then here be mindful of a type. It's WGSL, so that's extension for basically WebGPU shaders. And then we can work on our shader. And I forgot to do one thing, which is to zoom a bit, because it might be not that visible. So let's do this. All right, it might be better now. I'm just going to remove this, and then we can work on our shader. All right, so what are we going to need? So in the shader, we're first going to do vertex shader, and so the vertex shader is actually responsible for working with our vertices. Like I mentioned, this video does require some background knowledge about graphics, where the vertex shader is, what the vertex, where the fragment shader is. So, but let's just get started with it. So we're going to call it unlit material vs for vertex shader, and here we're going to pass built-in. I'm going to explain it in a second, but we're going to say vertex syntax VAD, and then U32 for unsigned integer. And what is the output here? So be mindful of this error. So what is the output? So we're going to define output as this vertex shader output, and here we're going to use built-in once again. So there are some keywords with WebGPU. For that I would recommend checking specs, but the first one is obvious one, and it's kind of position, right? The position of our vertex. So what we're going to try to do, if you see this canvas here, we're just going to try to draw a rectangle with 3 vertices. So 0, 1, 2. This will be our basically define our triangle. And so this vertex index is going to be index. So here it will be 0. Then it will run for this basically vertex. So the next value passed is going to be 1 and then 2, right? So it's going to run 3 times. And then this position is final position of our vertex on the screen, basically in the canvas element. So we're going to say vertex output here. Here we're going to say define positions of our triangle. So it's of type vector3f array. So it's going to be an array of vector3, 3 elements here. So this is just the length of an array, and then you can just say here, not like this actually, I think the shorthand is fine as well. And then we can say here, actually let's just make it vector4. Why not? It's less conversion, so just keep the last one at 1.0. I'm going to cover it in the future, what's the last element, but this is going to be quite clear, right? So because it's just a position, and I'm just going to modify this a bit so that we have something that actually fits the screen. So here minus, and here 0.5. I think that's fine. So what we're trying to do is go here. Sorry, we're going to start. It actually starts here, so this will be 0 in our case. Then we go up, so this will be 1, and then we go here, and this is the last one. It's just different order. It's kind of clear what it does. And then here we're just going to say vertex shader output. We're going to output that position, and we're going to fetch it from these positions, right? So we're going to use this vertex ID to fetch either 1, 2, or 3. So index, this will be here, it will be 0 index, here 1, and here 2. And then we can just return it out, and then we need to define fragment shader as well. And that's, I think this suggestion is fine. I'm just going to call it unlit material. We don't care about position yet, so it will have no arguments. And here we're just going to output vector4f, and we can say here at location 0. So this location, this is the pole location. You can actually output multiple colors. If you're rendering, for example, you might render to off-screen textures, and you might render to 3 or more textures, right? 1, 2, 3, 4 textures, and then you use this location. So this means just use location 0. So this is the first one. And then right now, for example, if you look at here, we have this idea of color attachment. So this location, right, when you use 0, is going to render to here, right? So this color attachment, which is well, the first one. Okay, yeah, let's just not output red actually, but green. So second argument is 1.0 for green, and then we can try to create our shader and pipeline, which will be used to render this to screen. So let's get started. And for that, I'm going to do, how am I going to do it? I might do it like this. I'm just going to create it here. It's probably fine for now. So what we're going to need to is import shader source from it's in source, I think, shaders, and then unlit material shader WGSL, and then you can use question mark and raw, and that will get basically all of this as a simple string in TypeScript. So we can use that to create our pipeline. So how do we do that? So we're just going to say here shader module, and then we need to pass that code in, and that's going to create our shader module, which is our shader. And then here we're going to say const render pipeline. I'm just going to remove this for a second. We're going to create a pipeline layout. I'm going to explain that in the future, just leave it auto for now. Label. So labels are just for debugging purposes. You can specify them, or you don't have to. I'm going to specify them because in the future, if you want to look at some debug information, it's kind of useful to know which pipeline has failed, which shader has failed, or whatever. So then we need to configure our vertex shader. So our module is our shader model. So we need to press our shader, and here entry point, it was called unlit material vertex shader VS for vertex shader. So yeah, this name here, right? And this will correspond to our fragment shader. But let's just finish this one. I think this is fine. And then we need to set up here fragment as well. Module, shader module, that's simple enough. Entry point, unlit material, FS for fragment shader, and then we just need to specify targets and our format. If you remember, we used this format when we configured Canvas, so we can use it here as well. And then we just close it here, and that's our render pipeline. Here it's complaining about this, so I think this might fix it. It does. It does. So we now have pipeline definition. We just need to paste it to our render path encoder, right? So, and render path encoder, like I mentioned, is what we draw in render pipeline to screen. So we're just going to say set pipeline, render path encoder set pipeline. So now we're using that pipeline that we created, and then we're going just going to say draw. First argument is 3. I'm going to explain it in a second. Second is 1, and fourth and last one are 0. So okay, if I save it, I have a bug, which is okay, it happens. Let's see what the bug is. It's probably just something in shader. It is 11. Okay, this needs to be vector 4. Alright, it works now. Let's just see. We have a triangle, and we do have our triangle. So just to explain some stuff here. Alright, so let's remove this. So pay attention to this built-in vertex index, right? So this is passed from the CPU, right? When we say here draw, right, you can see this first argument, which is actually 3, and that's saying, all right, we want to draw 3 vertices, right? And what are the vertices? They're here, right? These are our vertices. And then in our material shader, when we say, all right, we're not drawing 3 vertices, so it's going to pass 0, 1, and 2 as indexes. And where do you control the indexes? Well, you have this argument here where it says start from 0, right? If you take a look at here, third argument is first vertex, right? We start from 0. So that's how it works. The second argument you don't have to worry about. I'm going to explain it in the future. We're going to work with it. And then the fourth one, same thing. We're going to work with it. But essentially, you have this idea of instance, and we're going to use it as well. It's another built-in. Right now, it's not important. And basically, that's it on how we render this stuff. So if this was too hard for you, I have a slower pace tutorial series where we also cover all of this, and we'll try to create, but there it was imagined as writing a 2D game engine, sort of, so it's quite a bit slower and it won't deal with 3D. So if you're unfamiliar with graphics programming in general, jumping to 3D, I think it's way too much, so I would usually start with 2D. With that said, that's it for this video. Hopefully you enjoyed it. If you enjoyed it, please like, subscribe, and the next time, yeah, we might refactor some stuff so that it's more usable, draw quad, and hopefully we'll soon get to like some 3D programming. That's it for this video, and until next time.